Hi everyone, welcome to the class. So in today's class, we're going to talk about the problems on Laplace transforms, especially on the problems involving differential equations. So specifically in this part of Laplace transform, we're going to talk about questions on Laplace transform which are based on differential equations. So we're going to deal all the previous year questions based on differential equations of Laplace transforms. So this is a series of lectures that I'm taking on Laplace transform, and this is part 5 in the series of lectures. Right, you can, if you have not watched the previous videos, you can watch the previous videos. They are available on YouTube. Right, so let us start the topic. Give me a second. Yes. Right. So a differential equation is given for a system. A system can be given in the form of input-output relation. A system, an LTE system specifically, can be given in the form of impulse response as well. And a system, any system, can be given in the form of differential equation also. Okay, right. So this is one form of defining a system. So in this case, they have given differential equation, and they're giving the input to the system. And if you observe the input to the system, it is equal to, it is a constant signal from 0 to 2. So which can also be expressed as u of t minus u of t minus 2. So expressing in terms of u of t is more comfortable for us because we can find the Fourier transform or Laplace transform easily when the signal is in terms of step signals, right? And they're giving initial conditions. If you observe, they're giving initial condition of the output as 0 and 0, which means the initial conditions are 0. So if initial conditions are 0, then problem becomes much more easy. Initial conditions are given as zeros, which means we don't need to consider initial conditions while solving for output, right? Now, whenever a differential equation is given, we can find the transfer function of the system, because transfer function of the system also represents the system. Differential equation also represents the same system in a different format. It's very easy. Whenever differential equation is given, it is very easy to convert it into transfer function. And how to do that? Very simple. Just find the Laplace transform of the differential equation. So when you're finding Laplace transform of the differential equation, so you have to apply the differentiation property of bilateral Laplace transform. I'll just recollect the properties of bilateral Laplace transform here. So let's say if y of t is a signal with a Laplace transform, bilateral Laplace transform as y of s, then d by dt of y of t, d by dt of y of t has a bilateral Laplace transform of s into y of s. And similarly, if you do double differentiation for the signal in time domain, then bilateral Laplace transform turns out to be s square into y of s. Very simple property. The same property for unilateral Laplace transform changes a little bit. And you have to use bilateral Laplace transform or unilateral Laplace transform property, depends on initial conditions. If initial conditions are not there, for this differentiation, when you are applying Laplace transform, you can apply bilateral Laplace transform property itself. Whereas, if initial conditions given, you have to use the property of unilateral Laplace transform. I'll quickly recollect the basics of unilateral Laplace transform property also. I've discussed what is unilateral Laplace transform, and I've told you how to deal with problems on unilateral Laplace transform in the previous lectures. So let's say if y of t has a unilateral Laplace transform of y of s, then if y of t is differentiated in time domain, then what happens to the unilateral Laplace transform property? What happens is it is s into y of s minus small y of t equal to 0. Small y of t equal to 0. Similarly, if you do differentiation twice, d by dt of y of d square by dt square of y of t, unilateral Laplace transform is s square into y of s minus s into small y of 0. It is small y of 0. Time domain signal at t equal to 0, which is initial condition, minus y dash of 0, which means y of t, the time domain signal's differentiation value at t equal to 0. So this is the property of unilateral Laplace transform. So you don't need to get confused between bilateral Laplace transform and unilateral Laplace transform property. You can assume you can always use unilateral Laplace transform property whenever differential equation is given, because if initial conditions are not there, so substitute initial conditions to be 0, 0 here, 0 here, 0 here. The property turns out to be same as bilateral Laplace transform property. So if initial conditions are 0, the property of differentiation is exactly same for bilateral Laplace transform as well as unilateral Laplace transform. Only if initial conditions are non-zero, then there is a difference between the properties of bilateral Laplace transform and unilateral Laplace transform. So as for you to understand it, for you to remember easily, what I'll tell you is, always whenever differential equation is given, apply unilateral Laplace transform property only. Because when you apply unilateral Laplace transform, if initial conditions are these 0, you can substitute zeros, and this property will be same as this property, right? Now let us apply our basics to find the answer for this question. So I've given you some basics which are necessary for this problem as well as future problems. Right? They're asking us to find the Laplace transform of the output. So we know for an LTA system, we can understand from the differential equation, this is a differential equation which represents a LTA system. Okay, because it's a linear differential equation and a time invariant differential equation. Right. So if input is x of t and impulse response is h of t, output y of t is equal to x of t convolution with h of t. And input Laplace transform is x of s, system's Laplace transform or transfer function is capital H of s. So output Laplace transform is equal to input Laplace transform multiplied with transfer function of the system. Right. So what is the Laplace transform of the input signal? X of s is equal to u of t Laplace transform is 1 by s minus e power minus 2s divided by s, which is equal to 1 minus e power minus 2s divided by s. This is the Laplace transform of the input. Now if you take Laplace transform of the system, so of the differential equation, what we get is s square into y of s minus s into y of 0 minus y dash of 0 plus 5 into s into y of s minus y of 0, small y of 0, plus 6 into capital Y of s is equal to capital X of s. I don't know if you are seeing this. This is capital X of s, whatever I'm writing here. Fine. So now, if you substitute the initial conditions, y of 0 is 0, y dash of 0 is also 0. If you substitute initial conditions, then it turns out to be much more simpler. This equation turns out to be y of s, if you take common, what remains is s square plus 5s plus 6 is equal to capital X of s. Now, if you send x of s from the right hand side to left hand side, it becomes y of s divided by x of s, which is equal to 1 divided by s square plus 5s plus 6. So y of s divided by x of s, y of s divided by x of s is nothing but capital H of s. So we got the transfer function of the system, right? So if you want to find y of s is equal to x of s into h of s. X of s in this problem is 1 minus e power minus 2s divided by s into, what is the impulse transfer function of the system, capital H of s? It is 1 divided by s square plus 5s plus 6. S square plus 5s plus 6 we can write as s plus 2 into s plus 3. Now compare with the options. So option B matches. 1 minus e power minus 2s divided by s into s plus 2 into s plus 3. It's a simple question. Right? So let us move on to the next question. Right? System is described with the following differential equation. Y dot means it's differentiation of y of t. Now initial condition is given. Y of 0 is given. U of t is a unit step function. Y of t is. So they're asking us to find the output y of t. They're not giving x of t actually. They're not giving x of t. Directly they're giving u of t. So very simple funda. Let us apply Laplace transform on both sides of this differential equation. What we get is s into y of s minus small y of 0 plus 5 into capital Y of s is equal to u of t Laplace transform is 1 by s. Now they're asking us to find y of t, which means you have to find the inverse Laplace transform of capital Y of s. So y of s, if you take common, s into y of s minus y of 0 is 1 plus 5 into y of s is equal to 1 by s. So y of s, if you take common, it will be s plus 5 is equal to 1 by s minus 1. Okay, so y of s is equal to 1 minus s divided by s into s plus 5. Okay, I'll be back in a minute. You can find y of t in the meantime. One second. It is, if this 1 is sent out to the other side, it becomes 1 plus plus, right? Yeah, it should be 1 plus s divided by s. This s plus 5 onto the other side becomes s plus 5. So this is equal to, so if you take partial fractions, it becomes, if you substitute s equal to 0, it becomes 1 by 5. And if you substitute s equal to minus 5, then it becomes s equal to minus 5. If you substitute, it becomes minus 4 divided by minus 5, which is 4 divided by 5. One second. This is y of s only. We are supposed to find y of t, right? Okay. So if you are finding y of t, since there is no ROC given, by default ROC is right-sided ROC, because by default the systems, when the differential equation is given, you can, when no information is given, you can assume it is causal signals and you can solve the problem. So ROC here can be, so the poles are 0 and minus 5. So ROC is a real part of s greater than rightmost pole. The rightmost pole among 0 and minus 5 is 0. Right. So the inverse Laplace transform will be 1 by 5 into u of t plus 4 by 5 is 0.8 into e power minus 5t into u of t. This is the exact answer, but if you take 1 by 5 can be written as 0.2 plus 0.8 times e power minus 5t into u of t. So sometimes they don't give u of t in the answers, u of t in the answers, because they assume the output is causal, so that's why they don't write u of t generally sometimes. But exact answer, if it will be more appropriate if they have given u of t, but since u of t is not there in any option, so you can assume that u of t is present. Since they have assumed it is causal, they are not writing u of t. Okay, so you can compare and you can pick the options. It is 0.2 plus 0.8 times e power minus 5t. Very good. So if you want, you can cross check also. So if you put t equal to 0, so they have given the initial value as 1, right? So if you put t equal to 0, it is 0.2 plus 0.8 is 1. It is matching, right? Yeah. Next question. So let us move on to the next question. So that looks like a very complicated question. It looks like a very complicated question, but it's not actually a complicated question. Let us do this question. So a causal LTE system has 0 initial conditions. They're saying 0 initial conditions. Yeah. And impulse response h of t. Input and output are given by the constant coefficient differential equation. Yes, this is the differential equation. Let another signal g of t be defined as, g of t is defined in terms of h of t. Okay. And if g of s is a Laplace transform of g of t, then the number of poles of g of s. So what we are supposed to find is the Laplace transform of g of s we want to find. So let us find this. So let us find Laplace transform of this signal. It is equal to alpha square into, so whenever differential equation is given, you can assume you are finding unilateral Laplace transform. So the property of unilateral Laplace transform for integration of the signal, if you remember, we have discussed in the part 3 of Laplace transform series. I have explained clearly how we get the, what is the derivation of integration property also. For unilateral Laplace transform, when integration is from 0 to t, what happens is h of t Laplace transform is h of t, h of s, capital H of s, and if it is integrated from 0 to t, the Laplace transform will be divided by s, plus d by dt of h of t Laplace transform is s into capital H of s, plus alpha times capital H of s. So this, all this is equal to g of t Laplace transform is g of s. Now if you observe carefully, so h of s, if you take common, h of s if you take common, what is left inside is alpha square divided by s plus s plus alpha is equal to g of s. So g of s is equal to h of s into, so if you take s outside, it becomes alpha square plus s square plus alpha s. So we can write like this. Now we don't know what is capital H of s. They are asking us about how many number of poles are there in G of s, capital G of s. Right, let us find capital H of s. Capital H of s is nothing but the transfer function of the first system. So if you want to find the transfer function, let us take the Laplace transform. Yeah, here I'm not taking initial conditions because initial conditions are not given, so I'm assuming them as 0. So I'm not writing the initial conditions because dy dt of h of t, if you write the property, it is s into h of s minus h of t equal to 0 we have to write. Since we are assuming initial conditions as 0, I'm not writing the initial condition part. Here also, they are giving that in 0 initial conditions. So let us apply the Laplace transform property. It is s square into y of s plus alpha into y of s, sorry, alpha into s into y of s, s into y of s plus alpha square into y of s is equal to capital X of s. Okay, so this implies, so if you take y of s common, it becomes s square plus alpha s plus alpha square is equal to capital H of s. So from this you can find y of s divided by capital X of s is equal to 1 divided by s square plus alpha s plus alpha square. So this is nothing but capital H of s, right? So we got capital H of s. I did not write minus s into y of 0 because initial conditions are 0. That's why I'm not writing those terms, whatever we have discussed here. So these terms are becoming 0 because initial conditions are 0. Right. Now let us substitute capital H of s here. So capital H of s is given as 1 divided by s square plus alpha s plus alpha square into this 1 by s is there. And in the numerator it is alpha square plus s square plus alpha s. If you compare these two, s square plus alpha s plus alpha square, these two terms are getting cancelled. So g of s is finally 1 by s. How many poles are there in g of s? Only one pole. That to at s equal to 0. If you want, you can find g of t also. G of t is inverse Laplace transform of g of s, and that is equal to g of t. 1 by s inverse Laplace transform is what? U of t only, right? Okay, fine. So that is the solution for this problem. It's an easy question, though it is looking very complicated. Whenever differential equations are involved, so always remember that Laplace transforms will help you a lot. Next question. So this is a very good question. So here initial conditions are given. Right, as always, same procedure. Whatever I've discussed in the first slide, you can go ahead with that. The same properties. Initial conditions are not zeros. So we have to apply the property of differentiation based on unilateral Laplace transform. So let us apply the differentiation, sorry, Laplace transform on both sides. S square into y of s minus s into y of 0 minus y of 0 plus 2 into s into y of s minus y of 0 is equal to 0. Laplace transform is 0 only. Now if you take y of s common, it will be s square minus, sorry, plus 2s, s square plus 2s. One second, I forgot to write this term. Y Laplace transform is y of s is equal to 0. So y of s, if you take common, s square plus 2s plus 1, and it is equal to, okay, let me substitute. So what is left is minus s into y of 0 is 1 minus y of y dash of 0. Sorry, this is y dash of 0, right? I did the property by mistake. It is s into y of 0 minus y dash of 0. Yes, what is y dash of 0? That is also 1. Next, what is remaining is plus 2 into minus y of 0 s minus y of 0 is 1 is equal to 0. The remaining terms, so these three terms we have combined already here, and the remaining three terms, 1, 2, 3 terms we have written here. So y of s is equal to, so if you send this s, this is s minus 1, this is minus 2, minus 1 minus 2 is minus 3, minus s minus 3 onto the other side becomes s plus 3. and this s square plus 2s plus 1 onto the into the denominator, it becomes s plus 3 by s square plus 2s plus 1. So we can also write it as s plus 3 by s plus 1 whole square. So what they're asking us to find is the solution of the differential equation. Whenever there's a solution, they're asking us to find the output only. Instead of saying output, they can also say solution of the differential equation. So we are supposed to find y of t. Y of t, if you want to find, you have to find inverse Laplace transform of y of s. We have discussed in one of the previous classes how to find inverse Laplace transform very well. So I've given you the procedure also. So the procedure is first the first step in the procedure is find the partial fractions. The partial fractions for this Laplace transform is s plus 1 plus 1 by s plus 1 whole square. So can you tell me what should be the value here? It could be 1, and here it should be 2 units. I think that should be sufficient, I guess. Yeah, it should be sufficient. S plus 1 plus 2. Yes, it is sufficient. Now if you find inverse Laplace transform, so 1 by s plus 1 inverse Laplace transform is e power minus t into u of t plus 2 into 1 by s plus 1 whole square inverse Laplace transform is t into e power minus t into u of t. So which is equal to u of t if you take common, and e power minus t also if you take common, what is left is 1 plus 2t. So the answer is option B. So you might have got confused here in finding the inverse Laplace transform of 1 by s plus 1 whole square. I'll just recollect. U of t Laplace transform is 1 by s, and t into u of t or r of t Laplace transform is 1 by s square. Now if you substitute, if you multiply with e power minus at into t into u of t, the Laplace transform is multiplication, shifting property. If any signal is multiplied with e power minus at, in the Laplace transform, replace s with s plus a. So ROC will be sigma greater than 0, sigma greater than 0, sigma greater than 0. Sorry, here sigma, it should not be sigma greater than 0. My mistake. Let me write it once again. Here it should be. Let me write as real part of s. Real part of s greater than 0 because the pole is 0. And it is right-sided signal, so ROC should be right-sided. And here S is replaced with S plus A greater than 0, which means real part of S greater than a real part of minus A, a real part of minus A. So if A is real, then you can write it as real part of S greater than minus A if A is real. But if it is not real, you have to take real part of minus A. Right. So this is the Laplace transform of e power minus at into t into u of t. So whenever squaring is happening, it means it is because of multiplication with t in time domain. Because squaring happens only because of differentiation in Laplace domain. If multiplication in time domain with t results in differentiation in Laplace. So this property also I've discussed in the previous classes, previous lectures on Laplace transform. You can go through them. Fine. So we have covered the previous year questions based on differential equation. So just follow the procedure that I've discussed. Very simple procedure. If you know basic Laplace transform, you can solve the questions on differential equation very easily. But if you want to solve the questions on differential equation, you should know how to find inverse Laplace transform also very well. And one more thing is you should know how to find partial fractions also very well. Without knowing partial fractions and without knowing how to find inverse Laplace transform, these questions will take time. Okay. Fine, so that's it from my side. So this is the 5th lecture on Laplace transforms. So I've covered almost all the questions on Laplace transform, previous year questions on of GATE on Laplace transform. So in the next lecture, I'll take one more lecture in which I'll discuss the models which are not covered in the previous lecture and this lecture. I'll be covering different models of Laplace transform problems in the next lecture. Okay, fine. So give me if you can give me some time, I'll discuss a little bit about subscription. So I teach an Unacademy platform. So I teach these two subjects, signals and systems and communication systems. So if you want to attend my complete classes, so you can take subscription on Unacademy platform. So let me give you the details of subscription. So one important announcement is I'm starting my course on communications on 26th of June 2020. So if anybody is willing to attend the course, you can take subscription as soon as possible. Right. So if you're taking subscription, don't forget to use this code for getting extra discount. Right. So what if you take subscription? So you're taking subscription not just for my classes. Okay, if you take subscription, you can attend my classes. Along with that, you can attend every teacher's lectures that is available on Unacademy platform. So every faculty, every expert that is available on Unacademy platform, you can access everyone's lectures, right? So once you take subscription, whatever lectures I've taken in the previous months, previous years also, you can attend all those lectures. So these are all the courses that I've taken on Unacademy platform in the last 1 year. So all the lectures that I've taken are all live lectures only. So where students attend live classes. So but all those lectures are recorded and they are available in recorded format. So you can watch the recorded classes also as per your speed, or you can attend the live classes also, which will happen regularly. Every 2-3 months, the same course will be repeated on Unacademy platform. Right. So I'm just showing you this slide just to show what kind of faculties, teachers are available on Unacademy platform. I'm just showing some 5 people here, but there are many other excellent teachers available. So you can see the experience of the teachers and expertise or qualifications of the teachers. They're extraordinary teachers. So for ECE especially, the team is amazing. So trust me guys on this. So it's an amazing platform. So if you're really serious about your preparation, we are there to help you guys. So the last and the most important point is the subscription fees. The fees for subscription is very less, very less. So for 1 year, the subscription fees is just 25,000, and you can take subscription for a lesser number of months also. So based on your requirement, you can take the subscription for a certain number of months as per your requirement. So it's better if you are having confusion on how many months to take, it's better to take for 12 months. That's the best option. But if you are studying in your engineering, it's better to take a subscription for 24 months because the fees will be very less. So compared to 12 months, it's hardly just 5,000 extra, right? So the quality that we give is top notch. It's better than the topmost offline coaching centers available in the country. So, and the fees that we collect is hardly 1/3 or 1/4 of what the best offline coaching centers collect. And but we have more advantages than offline coaching centers, and I'll just name a few advantages. So for example, we'll conduct exams every week. So for example, if I'm teaching communications class, so every day I'll be teaching for 2 hours. So Monday to Friday I'll be teaching the classes, let's say 10 to 12 hours. I'll complete one chapter, let's say. On Saturday I'll be conducting an exam on whatever syllabus I have covered. So it means every week you'll be revising and you'll be writing the exams and you'll be testing on yourself. So this kind of facility is not available on offline coaching centers. And next thing is, let's say if you don't, let's say there is a particular topic which is tough to understand for you. Now, if it is an offline coaching centers, you'll listen to the class. If you don't understand, you cannot do anything about it. So you have to go through some textbook, or you have to put an extra effort to understand the class. But whereas here, let's say that there is a particular topic which is tough to understand. So you can watch the live class. You can understand as much as you can understand. And after the class, recording will be available. You can watch the recording once again to get a better understanding. That is also an option. And one more advantage is, let's say if there is if you are following a faculty for a particular subject and you are not able to follow that faculty for some reason. So what you can do is, there are multiple teachers available for the same subject. So you can attend the lectures of some other teachers also, right? So that option is also there on Unacademy. Whereas offline coaching centers, whether you understand it or not, it doesn't matter. So the faculty will not change. Right, so you can make use of this platform. This is an amazing platform. It's up to you how good you make use of it. And the test series is also available on the platform. And if you can use this code, this is my name itself. This is the code. You can note this down. If you're taking subscription any future point of time, you can use this code. So already the fees is less, and it will get further reduced if you use that code. Once you use that code, the fees gets further reduced for any subscription, for any number of months subscription. So any number of months, irrespective of the number of months, the facilities available on the platform are same. Don't think that 1 month subscription, the facilities will be less. No. For all number of months, same facility, but the duration for which you avail the facilities are different. Right, so that's it from my side. So these are my contact details. This is my Telegram ID. You can contact me for anything that you want to discuss with me. And this is my Telegram group. So where I'll be discussing the doubts on signals and communications. So if you have any doubts on signals and communications, you can add yourself to this group, and you can ask the questions in that group. You can post the questions in that group. Right. So that's it, guys. Thank you so much. Have a good day. We'll meet soon again in the next lecture or in future classes also on the Unacademy platform. Thank you. And don't forget to follow me on Unacademy page. So if you follow me on Unacademy page, you'll get updates on my special classes, free classes that I take, and regular courses. Whenever I start, you'll get an update on the courses, special new courses that I start. Right? Thank you so much. Have a good day.